Hi, we're going to start week 2 on section r.2, which begins on page 9 in your textbook, talking about integer exponents. From section 1, you'll remember that integers are positive whole numbers, negative whole numbers, or 0. So those exponents that we're going to be talking about are going to only be integers. Raising a number to a power indicates repeated multiplication, and that's what an exponent does. It indicates repeated multiplication. The example that you see here, 6 to the power of 4, means that 6 is multiplied by itself 4 times. So you would have to take 6 times 6 and get 36, take 36 times 6 and get that result, and then take that result and multiply it by another 6. You would multiply it 4 times. In this example, 6 is called the base. It's the number I call down on the flat part, and the number up in the air, the 4, is called the exponent. So that's what it looks like for math, 6 to the power of 4. What it looks like for algebra using letters is a to the power of n. A can be any real number. In the example above, a would be like the 6, and n is the positive integer in this example, and that number in the previous example would be n would be equal to 4. So if a is multiplied by itself n number of times, and we don't know what n is, we still say that n is the exponent and a is the base. On page 2 of this section, we have several examples. There are a number of 3's there that are multiplied by themselves. On the left side, they're kind of hard to see, but if we count them up, there are indeed seven of them. So this would be 3 to the power of 7. Example 2 is there are 5 negative 2's multiplied, so we put negative 2 inside the parentheses and put it to the power of 5. Example 3 is that we count them up and there are 4 2's, so it would be 2 to the power of 4. Down below, I've asked that we evaluate some of the examples. So the first one, 2 to the power of 4, means 2 times 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. The second example is negative 2 with the parentheses around it to the power of 4. So it means that there are 4 negative 2's multiplied together. So it would be negative 2 times negative 2 would be a positive 4. Positive 4 times a negative 2 would be a negative 8. And a negative 8 times a negative 2 would be a positive 16. So the answer is the same as it was in number 1, but arrived at a different way. Problem number 3 is a different example. If we actually look at the sign in front of it, that's really like a subtraction sign, and the number up in the air is an exponent. So if we go back to the first week, we remember the rules for please excuse my dear Aunt Sally. So exponents come before addition and subtraction. Addition and subtraction is the very last thing. In other words, in that problem, if you take your thumb and cover up the minus sign, all you see is 2 to the power of 4, exactly like problem number 1. Then you bring the minus sign back in, and it means that it's minus 16. So if you would want to note the difference between 1, 2, and 3, there are some of your homework problems that will have an example for your homework very similar to these. And the last example we have is 3 to the power of 3, which is 3 times 3 times 3, or 3 times 3 is 9, and 9 times 3 is 27. On the next page, we're going to talk about a special case, and that's when the exponent is a 0. These are two things that you might want to put on a note card so that you can have easy access to. A to the power of 0 is equal to a 1. That means that anything to the power of 0 is equal to a 1. There is one exception, and that a cannot be equal to a 0. 0 to the 0 is not defined. I will not have any of these on a test. There may be some of these kind of problems on your homework, but they will not be on your test, and they are not on your practice tests. A to the power of 0 is equal to a 1 may be on one of your tests, but 0 to the 0 power will not be. So that a can be anything. The examples that we have here are 3x to the 0. The 3 has an exponent, and its exponent is actually a 1 for the 3 to have an exponent of 0, you would have to have parentheses around the 3 and the x. So 3's exponent is 1 and x's exponent is 0. So anything to the power of 0 is equal to a 1, so you replace the x to the 0 with a 1, and we essentially just have 3 times 1 or 3. The second example does have parentheses around the y and the x, so that means anything to the power of 0 is equal to a 1, and that expression in the parentheses is no exception. And then the third example there is 10 to the power of 0. Anything to the power of 0 is equal to a 1, and so 10 to the power of 0 gets replaced by a 1. X's exponent is actually a 1, and we can have it stated as x to the 1 or just leave it as x. On page 4 of your lecture notes, we're going to talk about how to express things if we have negative exponents. Remember, the definition that we used for an exponent was indicated repeated multiplication, but those were all for positive exponents that we were talking about. So we're going to learn how to change a negative exponent and make it a positive exponent. The rule that you have here and in the textbook, it says if you have x to the power of a negative n, then you can take that base and that power and move it to the opposite spot. If it's on top, it goes to the bottom, and the only thing that changes is the sign of that exponent. So it went from being a minus n to being a plus n. The opposite is also true. If that x to the negative n is down on the bottom, then you can bring it up to the top, but it works the same either way. Wherever you have that exponent, when you move it to the opposite spot, then the sign of that exponent changes values. As we go through the textbook, I would like you on your practice test and on the test to not leave any negative exponents in your answers unless you're using scientific notation. For your homework, you may go ahead and turn in things with negative exponents. I know some of the examples in the textbook have it. So on your homework that you have that's assigned every week, you may leave answers with negative exponents. For the practice test and for the real test, I'll have noted on there to please not leave any negative exponents in any of your. On page 5 we have quite a few examples. 5 to the power of negative 2 can be written with a top and a bottom, so it would be that number over a 1. The 5 is the base and its exponent is a negative 2. We take the base and the exponent and move it to the opposite spot and change only the sign of the exponent. So it becomes 1 over 5 squared, which would be 1 over 25. As you do your problems, you can leave your answers, if they're a number to an exponent, you can leave it as a number to an exponent. If you do go ahead and, for instance, change that to 25, then it must be right. For example, if you took 5 times 2 and put 1 over 10, I would count that wrong, but I would accept 1 over 5 to the power of 2, or 1 over 25. Problem 2 is similar to number 1. 5 to the minus 1 could be written as 5 to the minus 1 over 1. When we take the base and we ask if it has a negative exponent, and it does, then we move it to the opposite spot and change the sign of the exponent. So 5 to the minus 1 is on top, we bring it to the bottom and becomes 1 over 5 to the first power, or simply 1/5. On problem number 3, it's the first one where we have a negative exponent in the denominator at the bottom of the fraction. We're going to take that exponent and we're going to move it to the top. The base stays the same, but only the sign of the exponent changes. So we could write that as 5 squared over 1, or 5 squared, and a square means an exponent of 2, or we could have 25 there. In example number 4, we have 1 over 10 to the minus 4th power. The base is 10, its exponent is negative. We want to move it to the opposite spot. It's on the bottom, it's going to go to the top. So we have 10 to the power of 4 over 1, which is simply 10 to the power of 4, or we could write 1 followed by 4 zeros would also be On page 6, we're going to look at some more examples of negative exponents. On problem number 1, we have a base of x and its exponent is negative. We're going to move it to the opposite spot, and it becomes x to the second over 1. Problem number 2 is also very similar. And we're going to cut it off here actually and continue on the next section.